Hi friends! Today we will learn how to find the area and perimeter of basic shapes like the square, triangle, rectangle, and circle. Then how to find the area of a rhombus, parallelogram, and trapezium. And most importantly, we will learn how to find out the area and perimeter of regular polygons like the triangle, pentagon, septagon, octagon, and so on and so forth. And then we will learn how to find the area of a general quadrilateral. So let's start. Let's first revise how to find the perimeter and area of very basic shapes. Firstly, we have the square. The formula for finding the perimeter of the square is 4 times the side. That is 4 multiplied by the side, or side plus side plus side plus side. That is adding all of its sides or multiplying the side with 4 because all sides are the same. How do we find the area of the square? We multiply the side with the side. Let's move on to the rectangle. We find the area of the rectangle by multiplying its length with its width. That is multiplying the longer side with the length of the shorter side. How do we find the perimeter? Perimeter is the sum of all the sides, so you can use the formula 2 times length plus breadth, because we have 2 lengths and 2 breadths. Now how do we find the area of a triangle? The formula for the area of a triangle is base times height divided by 2. I repeat. The area of the triangle is base times height divided by 2. And the perimeter of the triangle is the sum of all of its sides. Next, we move on to the perimeter and area of a circle. You need to know the length of its radius. Circumference is the other name of perimeter. Perimeter is only used for polygons, and the circumference is used for the circle. So, circumference of a circle is 2 times pi times r, where pi is a constant value of 3.14. You can also use 22/7. And the area of the circle is pi times r squared. Remember, pi is a constant value of 3.14, or 22/7. Now let's move on to the parallelogram. How do we find the area and perimeter of a parallelogram? What is a parallelogram? A parallelogram is a quadrilateral in which 2 pairs of sides are parallel to each other. Like in this parallelogram, side AB is parallel to side DC. Side BC is parallel to AD. Now how will we find the perimeter of the parallelogram? Parallelogram has 2 pairs of equal sides, like we had in the case of a rectangle. So perimeter is calculated with the formula 2 times length plus breadth. Now let's learn how to find the area of a parallelogram. We find the area of a rectangle with the formula base into height. So in the case of a parallelogram, we find the area with the formula base into height. But in order to find the height of the parallelogram, we need to draw a perpendicular from any vertex to its opposite side. Like in this case, we draw a perpendicular from vertex A to BC. So AE is a line which is perpendicular to BC, drawn from vertex A. This is the height of this parallelogram. We can also draw a perpendicular from vertex D to a line which is extended from BC. That means we extend BC, say F, and then draw a perpendicular from D to CF. This is the height of this parallelogram. We can also draw a perpendicular from vertex D to a line which is extended from BC. That means we extend BC, make it F, and then draw a perpendicular from D to CF, and you will get the height of the parallelogram. So draw the height of the parallelogram, find the length of the height of the parallelogram, and also measure the length of the side. Like in this case, we will be multiplying BC with the height h. Now let's move on to the rhombus. What is a rhombus? A rhombus is also a parallelogram with all of its sides equal. So whenever we have a quadrilateral in which all the sides are equal, we use the formula 4 times the side to calculate its perimeter. So perimeter of the rhombus is calculated using the formula 4 times the side. Area is calculated with the formula we use to find the area of any parallelogram, that is base times height. And in the case of a rhombus, all sides are the same, so we may take any side and multiply with the height, and we get the area of a rhombus. I repeat, a parallelogram. Area, base multiplied by height. Perimeter, 2 times length plus breadth, or 2 times the sum of 2 different sides. Rhombus is also a parallelogram, where all the sides are equal. So the area is any side multiplied by height, and perimeter is 4 times the side. Now let's move on to the trapezoid. What is a trapezoid? Trapezoid only has one pair of parallel sides, unlike the parallelogram which has 2 pairs of parallel sides. In a trapezoid, you only have one pair of parallel sides. It is a quadrilateral with one pair of parallel sides, and the other pair of sides are not necessarily equal or parallel. The area of a trapezoid is found with the formula sum of the length of its 2 parallel sides divided by 2, multiplied by the height. I repeat, sum of the length of the 2 of its parallel sides, like in this case, side A1 is parallel to side A2, so area is A1 plus A2 divided by 2 multiplied by the height. And perimeter of a trapezoid is calculated just the way we calculate for any polygon, sum of all of its sides. So, add up the length of all of its sides to calculate the perimeter. Next, we move on to regular polygons. The square, pentagon, hexagon, septagon, octagon, nonagon, decagon, and any other regular pentagon. So how do we find the area of a regular pentagon? We had the formula. First, revise what is a regular polygon. In every regular polygon, the length of its sides is equal, and the measurement of all angles is also equal. For example, this square, length of the 4 sides is the same, and also all the internal angles are 90 degrees. And another example is this equilateral triangle. This length of all the sides is the same, and all the internal angles measure 60 degrees. And here we have this pentagon. Length of all the sides is also all the same, and all the internal angles measure 108 degrees. In the case of a regular hexagon, that is polygon, we have 6 sides. All of its internal angles measure 120 degrees, and the length of all its sides is obviously the same because it is a regular hexagon, septagon. This has 7 sides. The length will all be the same, and the internal angle will always measure 128.5 degrees. In a regular octagon, that is a regular polygon that has 8 sides, length of all the sides will be the same, and the internal angle will always measure 135 degrees. These are the characteristics of a regular polygon. Now let's see how we found the perimeter and area of a regular polygon. Finding the perimeter is always easy. It is just the sum of length of all the sides of a polygon. In the case of a regular polygon, it is very easy. Multiply the length of one side with the number of sides, n. So, in the case of a triangle, you will multiply the length of the side with 3. In the case of a square, you will multiply with 4. In the case of a pentagon, you will multiply the length with 5. Similarly, in a hexagon, you will multiply with 6. In a septagon, you will multiply with 7. In an octagon, you will multiply with 8. And in a nonagon, you will multiply with 9. And in a decagon, you will multiply with 10. It is very easy to find the perimeter. Let's see, how do we find the area of a regular polygon? In order to find the area of a polygon, the formula is half multiplied by s. That is the length of one side of a polygon multiplied with a. All of this is then multiplied with n, where n is the number of sides of a regular polygon. Now you know what is n. It is the number of sides of a polygon, like it is 3 in the case of a triangle, 4 for a square, and 5 for a pentagon. And s is the length of the side. Now what is a? A is called the apothem. The apothem is the perpendicular connecting the center of the regular polygon to any other side of the polygon. For example, here we have this pentagon. Pentagon has 5 sides, so we will have 5 apothems, and we will all have the same length. I repeat, you must have the center of the regular polygon and then draw perpendicular to any side of the polygon, and you will get the apothem. If a polygon has n sides, it will have n apothems, and all of them will be of the same length. Like in this pentagon, you will have 1, 2, 3, 4, 5 apothems. All will have the same length. In the case of a hexagon, you will have 6 apothems. Now, why are we finding this apothem? Let's see the reasoning behind it. In the case of this pentagon, you can draw it as 5 triangles. If you divide this pentagon into triangles, what is the formula for finding the area of one triangle? It is half multiplied with base times height. In every triangle, the apothem is its height, and the base is the side. So in every triangle, area will be half multiplied by AS. And how many triangles do we have? We have 5 triangles, so we multiply half with 5 to get the whole area of the whole pentagon. I repeat, a regular pentagon can be divided into 5 triangles. How do we find the area of one triangle? Formula of finding the area of one triangle is half multiplied by base times height. In every triangle, the base will be the side, and the sides are all the same in triangles. And height will be the apothem. The center perpendicular drawn from the center to any one side of the pentagon is the apothem, and this apothem will be the height of the triangle. So every triangle will have the area half multiplied with A multiplied by S. So if there are 5 triangles, that will then be multiplied by 5. And this is our formula for every regular polygon. You need to know the length of the apothem and the length of one of its sides, and the area will be multiplied by S multiplied by N, and this whole thing multiplied with N. Let's have one more example. The hexagon. This is a regular hexagon. You can make 6 equal triangles in this regular hexagon, where each triangle will have the base as its side of the hexagon. And we know in a regular polygon, all the sides are the same, so S will be the same. And the height of every triangle will be a perpendicular drawn from the center of the hexagon to the side. In every triangle, you can draw the perpendicular from the center to the sides. You will have 6 perpendiculars, and these perpendiculars are called apothems. So you have 6 apothems and 6 sides in order to find the area of one triangle. What is the formula? The formula for finding the area of one triangle is half multiplied by base times height. Now the base is the side, and the height is the apothem, so the area of every triangle is half multiplied by S multiplied by A. So the area of every triangle is half multiplied by S and A. What will be the area of the whole hexagon? So the area will be half times S times A multiplied with 6. Similarly, in a septagon, you will multiply half times S times A with 7. in an octagon, half SA with 8. What is S? S is the length of the side of the regular polygon. A is the apothem. What is the apothem? Apothem is the perpendicular drawn from the center to any side. And every regular polygon, if n number of sides are there, n number of apothons will be there. The length of each side will be the same, and the length of each apothem will be the same. So this is the formula of finding the area of any regular polygon. Now let's learn how to find the area of a general quadrilateral. Here we have general quadrilaterals, A, B, C, D, which means neither a square, neither a rectangle, trapezium, or parallelogram. It is just a general quadrilateral. Neither of it has parallel sides or equal sides. This is a general quadrilateral ABCD. How do we find the area of such a quadrilateral? In order to find the area of a general quadrilateral, we divide the quadrilateral into two triangles by drawing a diagonal, any diagonal. And then we find the area of these two triangles to find out the area of the general quadrilateral. Now, in order to find the area of the triangle ABC, you need to know the height of this triangle. And how do we find the height? So we are drawing a perpendicular from B to AC. So AC is the base. And let this point be O. BO is the height of the triangle ABC. So you need to know the length of this diagonal and length of this height to find out the area of the triangle ABC, because triangle ABC half multiplied by the base and height. So you will multiply half with the length of AC and the height, H. Similarly, for triangle ACD, you will draw perpendicular from point D to the base AC, and you will find the area of this triangle with the formula half multiplied by base times height, where your base is AC and the height is H2. So you will need to know the length of H1 and H2 and the length of diagonal AC to find out the area of these two triangles. And the area of these two triangles will sum up to form the area of the quadrilateral. Here we have another example. We have to find the area of the irregular polygon. This is a polygon that has 1, 2, 3, 4, 5, 6 vertices. It is an irregular polygon. So how do we find the area of such a polygon? We will be dividing this polygon into triangles. Let's see how. Join the vertex A with D, A with C, and D with F to make triangles. And you got 1, 2, 3, 4 triangles. And now, here we have to find the area of this irregular polygon. You need to find the area of all these 4 triangles. Let's find them. Now let's find out the area of triangle 1. Triangle 1 is ABC. Now we know with the formula for finding the area of a triangle, it is half multiplied by base times height. The base is AC and the perpendicular will be B to AC. This is the height. So H1 will be the height of this triangle. We need to know the length of the height and the base, that is the side with the perpendiculars drawn, to get the area of the triangle. So we need to have the length of H1 and the length of HC. Now similarly, we will find the area of triangle 2. Triangle 2 is ACD. We need to draw the height of the triangle. So let's first draw perpendicular from vertex D to side AC. So H2 will be the height of triangle ACD. We need to know the length of its base AC and the height H2 to find the area of triangle 2. The formula is half times base times height. So it will be half times AC times H2. Similarly for triangle 3, which is ADF. We will be drawing a perpendicular from vertex D to base AF. You can choose any vertex from where we should draw the perpendicular to its opposite side, and the opposite side will be the base. We have chosen the vertex D and its opposite side AF, so we draw the perpendicular from D to AF. You can draw the perpendicular from F to AD or A to FD. Anyhow, from any vertex, draw a perpendicular to its opposite side. So H3 is the height of triangle ADF, and the area will be half times AF and H3. Similarly, for triangle 4, which is DFE, we'll be drawing the height of the triangle where we will be choosing vertex D. So we have to make a perpendicular to the side EF. So H4 is the height of the triangle DFE. And its area will be half times FE times H4. So you need to find the area of all 4 triangles and then sum them up to get the area of the irregular polygon ABCDEF.